This is 5.3a in elementary algebra, and this section is called Operations with Monomials. In the first two sections of Chapter 5, we did multiplication and division of exponents. And what we're going to do in this section is, it's really kind of a conglomeration of a bunch of different stuff. So we're just going to take one little bit at a time and kind of explain it and then move on to the next part. So there's a couple of definitions here. And the first definition is the word monomial. Okay, that always reminds me of a Muppet song called Phenomena, but anyway, look it up sometime. Monomial. A monomial is a one-term expression that is either a constant number, so the number 3 is a monomial, or the product of a constant and one or more variables raised to a whole number exponents. So basically what that means is a monomial could be the number 3. It could be a number with a letter. It could be a number with a letter with an exponent. It could be a number with a letter with an exponent with another letter with another exponent with another letter with another exponent. Okay, that's a monomial. So each of these 4 are monomials. So there's just one term. And one of the things that helps is there's not a plus or a minus sign with them. So it's not like x plus 3. That's not a monomial because there's a plus sign there. This is a monomial and this is a monomial. When you put them together, you get what is called poly, means many, a polynomial. Okay? And that's when you have more than one nomial. So anyway, that's what we have there as far as what a monomial is. The next definition here is the degree of that monomial. And the degree of the monomial is, you write down the monomial, so let's say that we have a monomial of 14x to the 4th y cubed. That's a monomial, and they're asking for the degree of that. The degree of a monomial will always be the sum of the exponents. So the degree of that monomial is 7. If we have a monomial like 3x, the exponent on the x is a 1, so the degree of that is going to be 1. If I have a number like -3, there is no exponent, is there? We've got a coefficient, but if we don't have a variable, then there is no degree there, so the degree on that is 0. All right, so that's pretty much what the degree of a monomial is. So let's jump over to example 5 already. I didn't realize we'd done that many. And they give me negative 3x squared times 4x cubed. And what they're asking us to do there is just multiply. All right, so see how we jumped? We just jumped from degrees of monomials to monomials. And there's really 2 steps in order to multiply these monomials. You multiply the numbers, and then you multiply the letters. Now remember, when you have 2 variables that you're multiplying, you add the exponents, and you get that. If I have, like, part B, they give me 4/5 x to the 5th, and they've got, how much of that in parentheses? Y squared. They have a time sign there. I'm not sure why. Times 10x cubed times y. We'll just leave the time sign out of there. All right, so again, first step, multiply the numbers. So remember, this is the same as 10 over 1, so 4 times 10 is 40. 5 times 1 is 5. X to the 5th, we look at that one and we look at the x cubed, because remember, you can't combine unless the letters are the same, and then you can combine those. So that's x, and we're multiplying, so we add the exponents. and then we look at the y's. And the y on this second one is a 1, so that and that is a 3. So the only thing we have to do is reduce the number right there. 40 over 5 is 8. And that ends up being my answer then for example B. All right, so let's look at example 6, and let's divide some of these. Now, we've already kind of had practice with these. It's just like multiplying. Okay, so remember when we were multiplying, what did we do? We multiplied the numbers, and then we combined our variables with the exponents by adding. It's the same thing over here with dividing. We're going to do the same order. We're going to divide our numbers. 15 divided by 3 is 5. I have 2 x's there. I'm going to take those 2 away. I'm going to take 2 of those away, and I'm left with 1 up there, or just 5x. And I'm done. All right, so let's look at one that's a little trickier, maybe not so tricky. And we're dividing it by 3xy to the 5th. Okay, so we divide our numbers. 39 divided by 3 is 13. And we look here, we've got 1x here, and we have 2 here, so let's get rid of one of those. And I have 3 there, and I have going to get rid of those 3, so that means I have 2 left on the bottom, right? Because I took 3 away from both the top and the bottom, and I get that for an answer. Okay, so let's keep moving along as we get into some other stuff. And let's look at example 7. Now, example 7, you'll notice they're asking you in sentence form. Divide 25a to the 5th b cubed by 50a squared b to the 7th. So they're saying take 25a to the 5th b to the 3rd and divide it by. By is the line there. 50a squared b to the 7th. Okay, so again, we divide. 25 divided by 50 is 1/2. Okay, we've got 2 a's here, we have 5 there. So let's get rid of the 2 there and get rid of these 2 up here, and that leaves us 3 on top. Then we look at our b's. We have 3 b's there, so let's get rid of those 3 and let's get rid of 3 of these. And that leaves us with 4 on the bottom. Okay? So see what happened? This line here stayed there, right there. And 25 over 50 is 1/2. So we put the 1/2, the 1 above the line, the 2 below to make it 1/2. We had a's left on top, and we had b's left on the bottom. And we just left it that way. Okay? Now again, the book will do it differently than that. And maybe the way that I'm doing it isn't perfectly mathematical theory per se, as far as I'm not really explaining all of the details about what's happening there. But it's exactly what's going on. It will always be right if you follow that method. So let's look at example number 8. We have 6x to the 4th y times 3x to the 7th y to the 5th, parenthesis, line, what do we have underneath there? 9x to the 5th y squared. Okay, so let's first of all, when we do these, we want to have a monomial on top. We don't want 2 different pieces here. And we want 1 on bottom before we complete it. So the way things work when you have things with this division line here, or fraction line, you do everything you can to simplify the top, you do everything you can to simplify the bottom, then you cross over the line to simplify. So to simplify the top, we're going to multiply. So 6 times 3 is 18. X to the 4th times x to the 7th is x to the 11th. Y to the 1st times y to the 5th is y to the 6th. So we simplified into one monomial there. Now we can cross over the line here because this is simplified and this is simplified. Well, what's 18 over 9? 18 over 9 is 2. Okay. In fact, let's draw a line here. Let's keep this line right there. And so it's 2 over 1, really, 18 over 9. So I look at my x to the 5th and my x to the 11th. My smallest one is the 5th, so I'm going to get rid of those 5 and get rid of 5 of these, leaving me an x to the 6th on top. I have more on top left. Now I'm going to look at the next one. I've got 2 down here and 6 here, so I'm going to get rid of these 2 and get rid of 2 of those, leaving me with 4 on top. Since there's nothing on the bottom except a 1, I can just get rid of this line and that 1 there. I mean, I could leave it there, but there's really no sense in doing that. Okay, so let's look at the next example. I'm going to pause here while I erase. Alright, so this is example 9, and this one here is the A part, and this is the B part. So this is completely separate, but I put it there just so I don't have to rewrite it again. Alright, so let's see what we do here with this part right here. Okay, so first of all, we take care of business here. That 2y, everything in that parentheses is being cubed. So 2 cubed is 8, and y cubed is just y cubed. Okay, let's do the same thing with the 3y. We're going to square the 3, and we're going to square the y. Now, we can multiply these. 9 times 7, or 9 times 8 is 72, and I have a y cubed and a y squared, so add those together, and I get that. Okay, so let's look at the one on the right. I'm going to simplify the top first. When I do that, I have, 6 times 6 is 36, because I squared the 6, I square the x, and I square the y. Okay, so remember, this is 4 times 2 because they're next to each other with nothing in between. Okay, and I'm going to put that over. 2 cubed is 8. X cubed is x to the 9th, multiply. Y squared cubed is multiply, and we get that. So, 36 over 8. Oh, goodness, how do we divide that out? All right, so let's see. 36 divided by 4 is 9, and 8 divided by 4 is 2. Okay, so there's that reduced. 4 goes into both of those. Okay, so we just took care of the numbers. Now let's take care of the x's. I have 2 x's here and 9 here, so let's get rid of these. And let's get rid of 2 out of those, and that leaves me with 7, right? Because I had 9. Now I look at these. I have 6 there, and I have 8 there, so I have 2 left when I get rid of the 6. When I get rid of 6 of the 8 up here. So this ends up being my answer, although not a real fun answer. So I'm going to stop at example 9 in 5.3a and start with 5.3b with multiplication and division of numbers written in scientific notation. And we'll start at that next video.